Namaste. Today we are going to solve linear equation using fixed point method and also compare it with Aitken delta square process. So let us first define what is the fixed point. Okay, a point P is said to be a fixed point of function fx if fp is equals to p. So let us consider an example. If fx equals to sin x, then when x equals to 0, f0 is equals to sin 0 is equals to 0. Yes, so fp is equals to p. So 0 is fixed point of fx equals to sin x. So this is the definition of the fixed point. Now we use this approach to find the equation for Aitken or Aitken delta square process. It is also known as acceleration of convergence. It is also known as acceleration of convergence. Okay, that is Aitken delta square process. So we are going to derive the derivation for this Aitken delta square process. Let P be a fixed point of function fx. Then by fixed point method, fp is equals to p. So let it be equation 1. Again, by fixed point iteration, method, we can give, or we have, f xn equals to xn plus 1. So this is equation 2. Now from 1 and 2, we can get fp minus f xn is equals to p minus xn plus 1. That is, p minus xn plus 1 is equals to f p minus f xn, changing the side only. So we use Lagrange mean value theorem for this purpose. For this right hand side value, we get p minus xn plus 1 equals to p minus xn into f c. That means derivative of c, where c lies between p and xn. By using Lagrange mean value theorem. Okay, or p minus xn plus 1 equals to p, p minus xn f dash c. Let this be represented by a constant k. So we get p minus xn plus 1 is equals to p minus xn into k, where k is equals to f dash c. Yes. Now we can write it into form. If it is n plus 1, there is n, so we can also write into this form: p x n equals to p minus x n minus 1 k. Let it be equation, okay, this be equation 3 and this be equation 4. So we divide equation 4 by equation 3 and get from 3 and 4 we get p minus xn by p minus xn plus 1 is equals to p minus xn minus 1 multiplied by k divided by p minus xn multiplied by k. So we cancel the k and we get p minus xn whole square equals to p minus xn plus 1 into p minus xn minus 1, and we open the braces. So p square a minus b whole square equals to a square minus 2ab into plus b square, and we multiply it, we get p into p square minus p xn minus 1 minus into plus minus, that is p xn plus 1, and minus minus plus xn minus 1 xn plus 1. Yes, or so p square is cancelled. Next one is there is anything to cancel, so it can be formed into xn square minus 2pxn equals to xn minus 1 xn plus 1 minus pxn minus 1 minus pxn plus 1. So let move the term with p in this side or all this in this side. So we get p xn minus 1 plus p xn plus 1 minus 2pxn is equals to xn minus 1 xn plus 1 minus xn square. Yes, or taking p common we get x minus 1 xn plus 1 minus 2xn equals to xn minus 1 xn plus 1 minus xn square. That is p equals to xn minus 1 xn plus 1 minus xn square divided by xn minus 1 minus xn plus 1 minus 2xn. Yes, is there is any error? When this part is moved from this, it becomes plus, yes, not minus, sorry, n plus 1, so n plus 1, so it be n plus 1. So this is our Aitken delta square process equation, and it can be written into simpler form. So we derive the simpler form of it, that is p is equals to x n plus 1, we add the term whole square minus 2x n plus 1 x n plus x n plus 1 x n minus 1 minus x square n plus 1, yes, plus 2x n plus 1 x n minus x n square. So this is the whole addition term. When we subtract and add it, we get this. The below term is same. okay, and it can be written in the form x n plus 1 x n plus 1 minus 2xn plus x n minus 1, yes, in this form, minus x n minus 1 minus xn whole square, okay, divided by x n plus 1, okay, minus 2xn plus xn minus 1. So this term and this term are same, so we get xn plus 1 minus xn minus 1 minus xn whole square divided by xn plus 1 minus 2xn plus xn minus 1, and it can be written in simpler form as xn plus 1 minus xn minus 1 minus xn is delta xn, so that is delta xn, okay, divided by, next one is, okay, outside the, okay, next one is, it is delta square xn minus 1. So this is the simpler form of Aitken's delta square process. Now we solve the problem by both fixed point and delta square process, okay. So let us consider an example as 2x plus cos x plus 3, that is, sorry, 2x equals to cos x plus 3. So that is, we get x equals to cos x plus 3 by 2. That means gx is equals to cos x plus 3 by 2. So now, so gx is cos x plus 3 by 2, yes. So let it be a is equals to, since we have trigonometrical ratio, so we must use radian, so radian is in 4, okay, alpha a is equals to cos alpha x plus 3, okay, it must be in division, yes, so equals to, okay, cos alpha x plus 3 divided by 2, and we have to change the value, okay. So first let us suppose the initial guess is x naught is 1.5, then x1 is equals to f x naught, so that is x equals to 1.5, yes, 1.5, we get 1.5353, okay, up to 5 digits. I will taking, okay, I will taking up to 5 digits. So x2 is equals to f x1, yes, so again equals to, what is the value of x now, 1.53536, so that is 1.51771. Again x3 equals to f x2, yes, so again its value is 1.51771, its value is 1.52949, and x4 is equals to, okay, 1.52949, okay, so its value is 1.52064. Again x5 is equals to, okay, f of x4 or g of f4. Okay, I have written g, so okay, for easiness we suppose f. So x4 is 1 point, what is the value of x4? 52064. So that is 1.52506, and x6 equals to f of x5. So that is equals to 1.52506. That is the value of f5 is, okay, 06. Okay, and we get 1.52286. Again, x7 is equals to f of x6. So that is 1.52286. We get 1.52395. x8 f x7 is, so that is 1.52395. That is equals to 1.52341. Okay, I have checked up to 8 iteration, and the value is, difference is 0.00030. So, and that is 5s. So for permissible error, let it be e equals to 0.001. So we have got the error range. So our final value is this. So that means the value of x for the given equation to be fixed point solution is x equals to 1.52341. So this is our solution. Now let us solve the same problem by using Aitken delta square process. Okay, so for Aitken or Aitken's, for Aitken's delta square process. So what are the necessary values for the Aitken's delta square process? Let's see. We need x naught. Okay, x naught equals to 1.5. Our guess was 1.5. And x1. What is the value of x1? We have got x1 as, this is 1.53536, and we need x2. Yes, x naught, x1, x2. So what is the value of x2? We have got 1.51771. So delta x1 is equals to x2 minus x1. It gives, what is the value of x2 minus x1? Okay, so 1.51771 minus 1.53536 equals to, it is 0.01765. okay, and delta x naught is equals to x1 minus x naught equals to 0. What is the value of x1? It was 1.53536 minus, what is the value of x naught? Initial guess was 1.5. So its value is 0.03536, and delta x naught, that is delta x1 minus delta x naught, is equals to minus 0.01765 minus 0.03536. we get 0.01765. we get minus 0.05301. Yes, now we use the formula, this formula. So x3 is equals to x2 minus delta x1 whole square divided by delta square x0. So that is x2. What is the value of x2? It was 1.51771 minus delta x1. What is the value of delta x1? Minus 0.01765 whole square divided by, what is the value of delta square x0? That is minus 0.05301. So what is the value we get when we use the formula? 1.51771, okay, minus 0.01765 square divided by minus 0.05301. That is 1.52358. Yes. So in first iteration we have got the value equivalent to the 8th iteration. Yes, 1.53523. So in first iteration we have got the value of 8 iteration in fixed point method. That means Aitken's delta square process is very faster. So in this way we have compared fixed point method with Aitken's delta square process. Thank you. I will be making video of Lagrange in next coming videos. Bye bye.